Hello friends, in this video we'll be solving few most important questions of uniform accelerated motion. So let's get started with the first question. A particle uniformly accelerating crosses point A with speed u1 and point B with speed u2. Find the speed at the midpoint of AB. Okay, so let's say these are the 2 points A and B. When particle crosses A, the speed is u1, and when it reaches B, the speed is this u2. Let the distance between them is x or s. So the midpoint, let's say midpoint is m, and the velocity at midpoint be let's say anything v dash. Okay, so this distance will be s by 2. Okay, so how we solve this equation? Just write down, we have to find v dash. This is the midpoint. So from A to M, we are writing equation v square is equal to u1 square plus 2as by 2. This equation is A to M. Initial velocity is u1, final velocity is v dash, which is the answer, and 2a is the acceleration, displacement is s by 2. Okay, and the next equation we'll write from A to B. Final velocity is u2 square, u1 square plus 2as. This equation is A to B. So whenever this type of questions come, that there are 3 points, in between one point will be there, write down the equation from initial to final point and from initial to somewhere midpoint. Okay, so from these two equations we can get v dash. We have to just eliminate 2as because it is not given, neither required. So from this value of as is nothing but v dash square minus u1 square, and we just put the value of as, so u2 square is equal to u1 square plus 2 times v dash square minus u1 square. On solving, we will easily get v dash or v square is equal to, we will get, this will be minus, तो add हो जाएगा u1 square plus u2 square whole root. Okay, this is square, and v will be u1 square plus u2 square whole root. This is a very famous expression. You should remember, if possible, that the speed at the midpoint is u1 square final velocity square plus initial velocity square whole root. In the next question, how much distance a car will cover before stopping with the retardation a and initial velocity u? What if the speed becomes n times? Okay, so let the car has a velocity u and stops here, so the final velocity is 0 and it covered distance s. The retardation or the acceleration is in opposite direction, so we will say final velocity is 0, v square is equal to u square plus 2 minus a represent the retardation into s. So stopping distance, this is known as stopping, is nothing but u square by 2a. This is again a famous expression. Stopping distance is proportional to u square. S stopping is proportional to u square. So if u becomes n times, obviously distance will become n square times. For example, if a car moving with 50 km per hour stops in, let's say 10 meter, stops in 10 meter, so the speed is doubled, 100 km per hour. It will not stop in 20 meters, it will stop in 4 times, which is 40 meters. If the speed is tripled, 150, then it will stop in 90 meters. For example, if the speed becomes 4 times, it will stop in 16 times distance. Okay. In the next question, velocity of bullet becomes 1 by k times when it penetrates through a plank. Find the minimum number of planks required to stop it, assuming uniform retardation. Okay, let's say the plank is like this, and we have placed n number of planks like this. So if the initial velocity is u, it becomes u by k, or it reduces to half and so on. Okay, so by moving the first plank, let's say the thickness is x or s, retardation is a, and after n planks, these are n planks, so obviously the total displacement will be nx. Okay, and the final velocity will be 0. So we can say again, this is the initial point, this is somewhere in between, this is the final point. We'll write again equation from A to final point B and somewhere A to M. So A to M equation will give me V square, which is u by k square, is equal to u square minus 2ax. Minus sign indicates the retardation. And equation from A to B, finally 0 square is equal to u square minus 2a nx. Okay, so just place the value of 2ax here. We will get u square is equal to 2ax is u square minus u square by k square into n. Okay, just cancel u square, so we'll get n is equal to k square over k square minus 1. Okay, if it becomes half, let's say it becomes half, velocity becomes half, so k is nothing but 2. Okay, obviously sometimes it will come as a fraction. Okay, let's say n comes out to be, on placing k equal to 2, n comes out to be 2 square over 4 minus 1, so that is 1 point something. So you have to take an integer which is just greater than n. If it is fraction, you have to take integer just greater than n. In that case, that will be 2. Okay, for example, another example is k equal to 3. So it will be let's say k को कुछ और ले लेते हैं. Let's say k is 4 by 3. Okay, velocity becomes 3 by 4 times, means k is 4 by 3, and n will be 4 by 3 का square, 16 by 9, and 16 by 9 it will be 7 by 9. Minus किया तो we get 2 point something. 2 point something means n will be 3. Okay, so this is how we take the value of n if it comes out to be fraction just greater than that. The next question is, a particle is moving with uniform acceleration, covers 40 meters in first 5 seconds and 65 meters in next 5 seconds. We have to find initial velocity and acceleration. It could also be asked what is the displacement in the next 5 seconds or next 10 seconds, so on. Okay, if we get u and a, anything can be calculated. So displacement in first 5 seconds. Displacement in first 5 seconds is u into 5 plus half into a into 5 square, that is 40 meters. So this is the first equation. Displacement in first 10 seconds. Again, the equation is simply point A, point B, and somewhere in between. This is first 5 seconds, and this is the second 5 seconds. But we should write down equation from first to last or initial to final directly, and then A to M. So equation from A to B in first 10 seconds, u into 10 plus half a into 10 square. Otherwise we have to put another variable which is velocity at m. Okay, so is nothing but 65 plus 40. This is equation 2. From 1 and 2 solve for u and a. 2 equations, 2 variable. solvable, you will get U and A, and anything can be calculated after that. Okay, thanks, enjoy.